Hey everybody, this is Larry, this is Amigo Q3 of the Bi-Weekly Contest 170, Lexicographically smallest negated permutation that sums to target. Hit the like button, subscribe button, join me on Discord, let me know what you think about this one. So this one is kind of hard for me, honestly. I did kind of struggle with a little bit of it, and what I did is try to see if I could figure out a pattern. And what I did with that, how I come to do that is just by writing a for loop. Sorry, no, not this one. How I did that is just by brute forcing, right? Small numbers. So I will brute forcing, small ends up to like 10 or something like that. And you could see this in the live portion, by the way. Everything is out there. I brute force it just to see if I can notice a pattern. I did notice a pattern, but let's pretend I didn't do it that way for just a second. Then now you can kind of think about it as well, let's just say you have 1, 2, 3, 4, 5. Let's just start with 5, and of course this sums to 15, right? So that means that here you can go up to 15 or negative 15, right? I think that part most people should be able to get. And of course, if your target is outside of that range, then it is not possible, right? Also straightforward so far. The one thing to note is that, and this thing I kind of got early on, but I didn't really formulate it that well, is that it turns out almost every number is possible, right? Let's ignore the negative for now, right? For now, we can ignore the negative portion and just say, let's say we're only given 1, 2, 3, 4, 5. We can construct every number from 1 to 15, right? It turns out, right? Because you could do 1, which is just 1, 2, 3, 4, 5. Okay, you could just use one of the numbers. 6 is just 5 plus 1. 7 is 5 plus 2. So then now you can say that, everything goes to 5 plus 4. So it's going to be 7, 8, 9. And then now you have just these two. And then now, which is 9. And then you can say 9 plus 1, 10, 11, 12, right? So we could say 10, 11, 12. And then now we add this one, so then 12, we could add 13, 14, and then 15, right? So basically, all I'm saying is that, and you can play around, and there are different ways you can enumerate this to make it work, but my point is still just that, given that you have 1 to 5, you have 1 to 5, it sums to 15, it turns out you could construct every number from 1 to 15, right? However, now let's take out the negative. The thing with negative is that now, right? Now that we have negative, it's not just taking subset of these number. Is that when we each of these number has to be either positive or negative, right? And what does that mean? The way that I think about it, and this is not necessary, or it is definitely not the only way to think about it, but it is just the way that I think about it, is that okay, we start off with every number being positive. Then now we can just choose a subset of them to be negative instead. And when you have negative, what that happens is that the delta now is 2 times this, right? What I mean is that if you convert a plus 1 to a minus 1, well, that's a minus 2. So if you convert the plus 4 to minus 4, well, that's a negative 8, right? That's the delta. So that leads to two or these two things combined leads to sorry, I'm like have a little bit of a sore throat. Leads to the observation that, well, every delta is going to be 2 times this number, and as we said, we can construct every combination. So that means that, well, one is that you cannot construct an odd delta, right? So if the sum is 15. You cannot construct 14 because there's no way to just subtract 1, because you're taking away a number and then subtracting it. It's going to be 2 times, right? So that means that you do it's a very basic check of doing parity, right? Meaning that if the sum is odd, you can only have odd targets. Okay, and then the second part, which actually for me anyway, I don't know if this is true for other people, the lexicographically thing is actually a hint, because then now this leads to a greedy solution, right? Because let's say you're trying to do, I don't know, -8, right? Or I guess this is not possible, as I just said. Let's say -9. So -9, what does that mean, right? Well, let's say we start with 15. We want to go to -9. That's a delta of 24, right? And then now, of course, there are multiple ways to kind of pick these to go to 24, for sure. But we wanted the lexicographic smallest. And what does that mean? That means that the first number, we want it to be, we want the first number to be as small as possible, right? And the way that we make it as small as possible is just choosing the biggest number possible and then subtracting from it. That means that we do a negative. Oops, how did that happen? Technology. What the? Stop that. It looks like a birdie. Okay. Anyway, let's say you choose -5, then now the delta goes from 25 to 14, right? Because you went from +5 to -5. And of course, you want. And any answer that contains this will be the lexicographically smallest. And then now 4, well, we want -4, so then now this is -8, so then this is 6, and then -3, and then now 1, 2. And that's it, right? Because we greedily get the biggest number, which allows us to get the smallest number, which is the lexicographically smallest sum. And that's pretty much it. That's kind of the idea. Are you serious? I didn't put it on the drawing board? Oh my. Well, hopefully I described it well. Sorry, friends. I usually double check. I don't know. I don't know what happened today. But I didn't really. Okay. I don't know. I don't know if the drawing is super helpful. But all I said is that I think there are only 2 things that I did. Sorry, friends. I'm disappointed at myself. Trust me. Hopefully the words are good enough. And then but my point is still just that what I said is still true. Which is that from 1 to n, you can go up to the sum of all the numbers, right? The odd even parity, I mean, I kind of just drew it out a little bit, but it's not that intense. And then the delta, I just kind of worked my way through a little bit. But yeah, okay. So that being said, let's take a look at the solution, and that's basically what I did, right? First of all, early termination, right? And this is where I got a wrong answer because I forgot the absolute value. But basically, if the target is too high or too low, return 0, right? Otherwise, this is the possible total, and maybe we could have written this in a different way, but that's just the way that I win it. You can watch it during the live portion. If this is too small, then otherwise, then we just get the total. And if the parity is not the same, then we return empty because it's not possible. This is what we said about 15 and 14 and stuff like that, going, because you do 2 times the number, right? So then here that's what I did. How I described it is literally what I did. I set the delta. I did a thing, and then I just appended. And then at the end, and I count this down from the biggest number so that we can have the biggest negative possible. And then we just sort at the end, and this makes it n log n, and that's the answer. N log n time, O of n space. Of course, you do not need to do it this way. Or you do not need the sorting, sorry. Because, I don't know, I did the sort because it's lazy. But what you can do is, there are a couple of ways you can append this, for example, but you can also just keep track of the positive numbers and then the negative numbers, and then just combine them, for example. That will give you, linear time, linear space, and I think that's probably the better way to do it. And it's not really linear, it's O of n, where n is not the input size, right? So, in any case, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live during the contest next. Hoping I didn't do anything too silly. Okay. Let's grab because what does that even mean? N is equal to, okay. Sum of the elements is equal to target. This is already annoying. I do remember everything is possible, right? If the summation is possible, then everything is possible. Because you can treat it as because you have 1, you have 2, you have 3, 4. I think that's true. I could be wrong. So let's assume that it's true for now. Alright. Otherwise it's always possible. And then now we greedily target is always positive. Oh no, it's not. Doesn't seem so hard, but it's just so annoying. Like, I don't think there's any maybe it is hard for that reason though. I have some recollection of some parts of this, but I'm just like, I also remember struggling a lot on stuff like this, so I don't know. Is that true though? Let's say target is 4. Can you do it? Oh, you mean target is 1. Target is 1, then how you would do it? Don't think that's possible then, right? So maybe this is not the only case, it's not always possible. I mean, the lexicographically is not that hard, it's just a permutation. Fine, right? But then that's just sorting. Permutation is just adding or subtracting. So then now it's so for every number up to 10 to the 5th. 10 to the 5th is a huge number, right? So it's not like some sort of knapsack E pseudo polynomial DP. Okay. That's where I was going. So there may be a more greedy idea. Okay, how would you even do 1? 1 is not possible. Why is 1 not possible though? Well, the answer is because I tried all the combinations, but what is the... Can you do greedy in any other way? Is this one easier? No. This feels very zero summy, but it's 1 to the... I'm sorry, and I don't know. Okay, let's try, right? Let's take a look. Maybe I can figure out a pattern. That's what I need to do. Okay. Oh, I mean, I knew that, but I will just print this. 2, 4, 6. Okay, maybe that does tell me something. Okay, so then now. I might see a pattern definitely, right? But okay, so the total of 1 plus 2 plus 3 is 6, right? And then now you move either 1 on each side, 2 on the other side, 3 on the other side, and then so forth. Okay, so the sum is 3, 6, 10, 15. Right, so that's the pattern, and multiples of 2s after that is possible. Okay, we're working with something. Just want to verify a little bit more. I think I get the idea though. Yeah, 6, 7. Okay. So then this is actually even. I mean, this is definitely true. But then you have something like. Okay, total is equal to n times. Right. And if total mod 2 is not equal to target mod 2, then we return as well, right? And then now everything else is possible, but then how do you get it, right? You get it all by having it all on one side. And you also have to get the lexicographically smallest. Okay, so lexicographically smallest, I guess it allows us to do the tiebreaker because everything else is possible. Then now that means that you have to move the biggest numbers you can, right, for the lexicographically smallest. That just give us a hint. So then now we have delta is equal to the total minus target, right? So that's a number of things that we have to change. And then now we can just do a loop, right? So while delta is greater than 0, right? Okay, or maybe even like for I in range of n minus 1 maybe. I don't know if 0 counts, but if delta is greater equal to I, and delta subtract by I, and then we yeah, and then we just kind of do it that way, right? I else and start minus I, and then we sort answer, and then we just return it, something like that maybe. Right, I don't know why oh, I guess a lot of the stuff is just not possible, but and we have to subtract out 0, or not subtract out 0, just don't. Nope, it's this one. That's not right though. No, it's this divided by times 2, because you move 1 to the other side, you're double subtracting it. Okay, that is what I want, I think. Alright, YOLO submit. Maybe I'm a little bit wrong. Oh, okay, I mean, this having a case like this being wrong is fine. I forgot to test for negative numbers, to be honest. So So this part didn't hold up. What I meant is probably something like this. I knew I should. Yeah. I thought I would, but no, it should be okay. I thought about negative numbers here, but I didn't think about it in here because I just forgot early on. Alright, wasn't that bad. I mean, it was pretty tough actually, but okay. Anyway, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and all these problems. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.